Hi everyone, and welcome to our What's New in SAP HANA Cloud session in Q4 2024. My name is Susan, and I'm part of the product management team who is taking care of SAP HANA Cloud, and I'm excited to welcome you all to this session. Today, we'll be talking about the recent innovations we released with our Q4 release. But of course, we can in 1 hour not cover everything, so we'll only cover the top informations today. If you're looking for a comprehensive overview and more technical insights, I can definitely recommend to take a look at our technical documentation at help.sap.com or at the blog post my colleague Thomas just published in the SAP community. With this, I'm, as always, not alone in this call. I do have a bunch of experts here with me in the back end, and they are as excited as I to share a few innovations we're delivering, and they're also diving deeper in a few expert topics. So we do have Thomas, Rüdiger, Christoph, and Tesuk with me today, and we're talking about the following topics. As always, we're starting with a short general update with a few smaller innovations, and then we're moving on to the topic of elastic compute and scalability, which we will have Thomas presenting the detailed innovations. We will then move on to the topic of native multi-tenancy, which will be presented by Rüdiger. And after this, we're taking a look into the machine learning and natural language processing updates, including our own text embedding function with Christoph. And we will close our call with Tesuk, who is telling us a bit more about the SQL Plan Advisor. With this, we're already moving on to our general update. And I actually want to take a tiny look back. So in Q3, we had TechEd 2024, and HANA Cloud was actually one of the popular topics for TechEd. We had a few key announcements, and if you listen closely to the agenda, you can see a few of them will also be part of our webinar today. A few more outlined for Q1, but I just wanted to remind you there are a lot of resources. So if you want to learn a bit more about what we've announced at TechEd and what actually came out of these announcements, definitely rewatch our sessions. Take a look at the keynote where we actually demoed the Gen AI toolkit, and also have a look at the overview blog post for some more resources on the key announcements, for example, on native multi-tenancy, but you will also learn more about this later on in this call. Now, moving on to the first innovation for today, and we're of course heavily investing into data privacy and protection, which is why I want to mention two specific innovations this time within the webinar. So first, we deliver X509 certificate-based client authentication for schemas and HDI containers. With this innovation, we're giving our SAP HANA Cloud users a few more abilities. From now on, they are able to enable service keys to use the X509 client certificates. They can expose a dedicated certificate for each service binding. As well, they can rotate the certificates by creating new service bindings and deleting the old service bindings. From now on, service instances can have multiple service bindings with different certificates. And last but not least, applications can now also create a new binding, switch all connections to the new bindings, and then delete the old binding without any downtime. So the benefits should be more or less clear, but let me just reiterate on them real quick. So we're definitely adding a more secure way to verify user identities. We're adding zero downtime for credential rotation for schemas, and it is trickier to do forgery. So there will be less forgery because we're tying certificates to specific users and devices. This is, of course, only a short overview. So if you're looking for more information, there is more available in the service plan description that is linked here. So definitely check out more information within this link. Next, and as mentioned, still in the data privacy and protection space, once again, we're investing in our X509 capabilities. So from now on, X509 based authentication for Connect SQL statements is available. With this delivery, users can now make better use of session pooling scenarios, such as those that are supported by our Cloud Application Programming Model, or short CAP, where the active SAP HANA database user of an existing session is constantly switched. Also, the switch between users in existing sessions is offered by providing a valid X509 certificate of another user. Once again, this is definitely making your interaction more secure and efficient, and it is also an efficient way to provide user credentials within one session. This is improving our security definitely by relying on X509 certificate. Moving on, and we're still kind of in the data privacy and protection space, and I'm really, really excited. We already had one announcement in Q3, but we're once again adding another innovation in the private endpoint support space. Let me stress, BTP and HANA connections are secure by default. They use TLS encryption that is required, and it is also enforced for all network communications. Allow list filtering provides also access control for public IP endpoints. So as mentioned, in Q3, we already added the private IP endpoint support for AWS in HANA Cloud database. And with the Q4 release, we're now also supporting Google Cloud Platform's Private Service Connect. As a quick reminder, if you're wondering what the private IP endpoint service is, this is a cloud networking security option to reduce the exposure of your applications and servers to external networks. Currently, there is a limitation we want to keep in mind, so public IP endpoints cannot yet be disabled, but this actually should be the case in the future. So what we're planning in this space is also supporting the connection to SAP HANA Cloud Data Lake using the GCP Private Service Connect. We also are planning to support Azure Private Link, and as mentioned, the ability to fully disable the public IP endpoints for SAP HANA Cloud services. With this, we're already moving over to the last innovation of the general section, and I'm super happy to tell you that we're adding 2 new data centers this quarter. So we will have one new data center in Sao Paulo on Azure and another one on GCP in Sydney, Australia. We're once again investing in the availability in different regions, and we're therefore following our customers' wish to provide availability for HANA Cloud in the hyperscaler centers of their choice. That basically fits their strategy. With this, I'm actually already handing it over to my colleague Thomas, who will tell us a bit more about the innovations in the elastic compute and scalability area.
Thank you so much, Susan. And it's great to be part of the show again, especially as today I'm the one who is in the glad position to talk about really exciting innovations in that area, as you mentioned, and also to announce the general availability of a feature that we were looking forward to for quite a while. And we've announced it with TechEd, we've talked about it a bit, but now, as said, the feature becomes available to our customers for their consumption. And I think this is really a really big deal. Now let's jump right into the topic of elastic compute nodes, which will give you an extra amount of scalability for workloads that you are seeing on HANA Cloud to also use our resources in the most efficient manner. Now, what is elastic compute, or are the elastic compute nodes all about? So first of all, they are a means in HANA Cloud to scale out horizontally, so kind of giving you an extra node in SAP HANA Cloud that can take over certain workloads. These workloads are compute intensive in nature, and they are read-only. And once these criteria are met, you can kind of use such an elastic compute node to move a certain workload over to another node, which is taking load off your primary system, and also gives you, let's say, more scalability and more performance to kind of evenly balance your workloads onto resources that you bring up for a temporary basis. This way you can ensure performance with a very constant workload pattern, given that your use cases match to these criteria. Now, what does this look like in reality, and super crisp and super short? So what you can see here in the graphic is like a workload that you might see also running on top of your HANA Cloud system. So you have kind of an average load, which is like the light blue area. And then you see two peaks that are coming up, which like outpass a certain general threshold. Now, if you are facing such patterns regularly with your HANA Cloud system today, then typically you want to consider upsizing your system because you have to provide the resources for these peaks as well, right? And in this case, this means quite some upsizing. And for like a large amount of time, it means that systems are or like resources are idle. And with the Elastic Compute Nodes, we give you the possibility to, as the name says, elastically add additional compute capacity to your HANA Cloud system, which avoids significant oversizing and over-provisioning of your primary node, but gives you the flexibility to cater for such temporary peaks in a much better way. So in our example here, we have, for instance, provisioned a so-called coordinator or primary node, which is our index server, to be 16 vCPUs to cover basically the average threshold that we're seeing here as well. And to take care of the peaks that are coming in, we're adding for a certain period of time on-demand nodes, and we can route workloads based on workload classes to these Elastic Compute Nodes. That's very high level, the summary of what Elastic Compute Nodes provide, but now let's go right into the details to understand more what it's all about and how you can make use of the feature. So as I stated, this technology is really for read-only workloads because all write transactions are routed via the coordinator to the persistency, basically. The service can be used in different ways. So you can trigger the creation or the provisioning of Elastic Compute Nodes via API, but also via HANA Cloud Central, which I will demonstrate later on briefly. And basically, it gives you the possibility to make use of very equivalent index server features, but without a persistency being given. So it means you are not able to create normal tables within these Elastic Compute Nodes, but you make use of temporary tables. You can replicate data into Elastic Compute Nodes to make the query performance faster, but this is always just temporary. And one thing to also keep in mind, as this concept is not meant to be a solution for high availability or disaster recovery, the Elastic Compute Nodes are not integrated into these overarching concepts as well. So they are really just meant for handling temporary, extensive compute scenarios on your system. And then, as I stated, the workload routing to these specific nodes happens via workload classes. And that's what you can find illustrated a bit on the right with the graphics that I want to walk through now step by step. So typically the first step when you want to make use of Elastic Compute Nodes is the provisioning. So depending on your scenario, do you provision one or multiple Elastic Compute Nodes? These can be provisioned by REST API, as I stated, or via the HANA Cloud Central tooling. Now, what you already see is that with the scenario here, we see multiple tables being replicated into certain Elastic Compute Nodes. This is a conscious decision you have to take in order to optimize certain workloads running within the Elastic Compute Nodes. It is not a necessity, so you can also start without replication first and observe the performance. That would be our recommendation as a start. And then later on, once you have adapted the workload classes with giving a certain routing information, naming like which Elastic Compute Node would be used for a workload class, the workload, once it's coming in and once it is mapped to the workload class, will then be routed to the Elastic Compute Node and will be performed specifically on that Elastic Compute Node. So we're taking offload from the primary system, which would in the past have handled such workloads coming in. Now, the last or second last step in that process is kind of the adaptation of the workload classes again, as in case you no longer need these additional capacities. So you're basically changing the workload classes again, or you're removing the workload class definitions entirely if that is not providing any value anymore. And after that, you can deprovision the Elastic Compute nodes to also save cost on any resources provided that aren't relevant. So this really shows how you can balance the availability of resources and how you can make use of additional capacity coming in for your compute-intensive scenarios. Now, what are maybe some of the use cases that might map to that? I was talking about read-only workloads, but to illustrate that a bit better, we have two examples that I want to share with you. So first of all, we know that many customers run very compute-intensive scenarios on top of HANA Cloud, where like read access is quite often given, and it's not necessarily about writing significant data loads. So for instance, when analyzing data volumes, this is kind of the case, or when running planning on top of an application. And what you can see in the bottom is kind of a comparison of what it would mean if you would like upsize or scale up a certain primary instance to handle these incoming frequent loads that are somewhat following a pattern that theoretically could be offloaded to a concept that is much more temporary in nature. And contrast to that, on the right-hand side, you see kind of the TCO optimized way of how you can make use now of the Elastic Compute nodes, where you just for a certain period of time bring up these Elastic Compute nodes. In this case, it's a fairly like long duration. Actually, we see 2 months of usage of an Elastic Compute node, where this still provides benefit over running a system for like 12 months at a permanent time. Now, an example for such a scenario is, for instance, an intelligent data application that runs on top of HANA Cloud, which has really like compute intensive scenarios on top. So kind of planning processes, very heavy analytical jobs, or for instance, and that's also a very frequently known case by our customers, year-end or quarter-end jobs that are coming in. So especially here with that scenario, where we picked a year-end case where we said like, well, for the 2 last quarters, or maybe the last and the first month of the year, we're bringing in a new Elastic Compute node, and that Elastic Compute node will just run for 2 months and will just complement the system with additional resources. As said, also here, like you can for sure run table replications optionally, but this is something you can also decide on the go when you have the system up and running. Now, the second scenario is slightly different. Here, we're trying to illustrate how you can make use of Elastic Compute nodes to also ensure a fairly constant performance by application. So, for instance, customers running SAP Analytics Cloud on top of HANA Cloud sometimes make use of the same system also for applications that they have created natively and that make use of all the great values of HANA Cloud. And for such scenarios, you also want to make use of like resources that are tailored for specific purposes, and you want to maybe mitigate some of these peaks as they are coming up. And there also, the Elastic Compute nodes are a great opportunity to handle the workloads in a much more TCO optimized manner. Let's jump a bit into key considerations that are relevant when you make use of Elastic Compute nodes or thinking about that. So I already mentioned that everything starts basically with the provisioning of the Elastic Compute nodes via API or tooling. What you have to keep in mind is that the creation of the Elastic Compute nodes takes a bit of time. From our perspective, like the approximate startup time is roughly under 10 minutes. Best case, it's even under 5, but this is kind of the average that we were able to observe, which really is, from my perspective, a remarkable number, giving additional resources at your hands to such a great speed. Now, once the provisioning is done, you can decide about whether you want to replicate data into the nodes or not. This is something which will influence the query performance later on. But when you have, for instance, jobs that aren't running very long, it might, like the replication might just slow down the execution of the jobs because you need to wait until the data is loaded. So keep that in mind. Depending on your scenario, it might make sense to replicate data into the Elastic Compute nodes or not. but this is something you can definitely try out. During the Elastic Compute Node runtime, it makes sense to observe the workloads and to understand better like which workloads can be routed to the Elastic Compute Nodes or not. And last but not least, the last step is then, as I stated in the process flow, the deprovisioning and the adaptation of the workload classes, which is then kind of showing the end of the lifetime of the Elastic Compute Node. Just some additional key facts. I know it's a lot of content, but definitely very important for you to know about that. So we're happy that we can provide these Elastic Compute Nodes up to the size of roughly 2 terabytes each node. And in some, we allow up to 16 nodes being added to your HANA Cloud instances. So really a remarkable number, and this number accounts to every single HANA Cloud instance. The sizes vary a bit depending on the actual cloud service provider. And what you can also see here noted is that we're not supporting the high memory performance class for Elastic Compute Nodes. What we want to make you aware of is that the provisioning of the Elastic Compute Nodes depends very much on the availability of the resources at the cloud service providers. That holds true for HANA Cloud in general, but for sure also it holds true for the Elastic Compute Nodes. But we're in very close alignment with our cloud service providers always to ensure that the capacity is aligned. And last but not least, please also be aware that because of the on-demand provisioning of Elastic Compute Nodes, they incur higher costs than ordinary primary nodes or index server primaries coordinators. This is something to keep in mind, but we see that even with that additional cost for on-demand resources, still our customers can significantly benefit from the TCO optimization coming via Elastic Compute Nodes. Now, 2 things I want to show you right now in a demo, but maybe just briefly on slide is 1, the new possibility for you to provision and configure Elastic Compute Nodes in SAP HANA Cloud Central. And 2nd, a so-called advisor that we're also adding to the tool that will give you better possibility to understand which workloads can be routed to SAP HANA Cloud. Now, let me just briefly change my screen share, and I want to navigate you to the SAP HANA Cloud Central, where you can find the new implementation for the configuration of Elastic Compute Nodes. So first of all, let's take a look at the new opportunities you have in HANA Cloud Central. So over here, you can find a new ribbon, a new tab for Elastic Compute Nodes. And this gives you the possibility to see what's going on in terms of Elastic Compute with your HANA Cloud instance as of now. What you can see is that my instance right now has no Elastic Compute configured. So I have the possibility to manage Elastic Compute Nodes here. And we're jumping back into the overall configuration wizard of the database. And within that wizard, I have the possibility to add new Elastic Compute Nodes. I can give names, I can define the performance classes, as well as the size of the Elastic Compute Nodes. And once I provision an Elastic Compute Node, I have the possibility to then also manage workload classes and route workload classes to specific ECNs that I have just provisioned. So this is the entry point if you want to go the route of like a direct configuration. Now, one thing we have also added to SAP HANA Cloud is an advisor that gives you recommendations which workloads to route to a certain Elastic Compute Node of a given size. This is a really handy tool as it helps you to understand better which workloads classify for the usage of Elastic Compute Nodes. And what you can see here basically is, again, our HANA Cloud Central. And within the HANA Cloud Central, you can find a tab that or an application basically that's called Advisors. And once we step into the Advisors application, you already see a lot of recommendations that I have created up front. Now let's ignore them for a second because we want to start fresh. We want to use the Elastic Compute Node Advisor to get a recommendation for our system to understand like for which point in time we can make use of Elastic Compute Nodes. So what we see here is the consumption of memory and CPU over the last 7 days. And you see certain peaks. And now what I want to understand is maybe whether I can use for one of these peaks here an Elastic Compute Node. So I'm just trying to understand what's the time frame where this peak was coming up. It was like December 15th, basically from like 9 p.m. to 2 a.m. next day. So I'm selecting December 15th. We want to go with 9 p.m. at basically, we saw the peak stopping at 2 a.m. in the morning on the next day. And what I can do here now is configure the thresholds. So this kind of decides or gives guiding rules to the advisor to decide which workloads should be routed to the ECN or not, depending on a certain threshold being exceeded. And in my case, I'm changing the threshold to 20% because this equivalates the peak here, just to get a proper recommendation from our system. Now, what's happening is an asynchronous process is being started, and this process helps us to get a better analysis on the actual workload. The advisor will check all the workload classes being present, and it will give us a recommendation saying, well, this workload class is suitable to be routed or not. Now, you can already see that the advisor was coming back with a recommendation. So this is the one I have just obtained. And if I hit the recommendation, I can see that the tool is now suggesting the usage of ECNs for a user-defined time frame for every Sunday, because it's a repeating pattern, as we've seen, from 9 p.m. to 2 a.m. We can route one workload class, because this one is independent from the other ones, and it is largely just showing read access to an elastic compute node. And by this, we have an estimated saving as well and an estimated usage of ECNs. And this is explained by the pattern again. So also our advisor was confirming that the pattern as such was useful. With the current state of the advisor, we give you these recommendations, these insights into which workload classes can be routed. We also give you a recommendation in terms of the size of the ECN node, and you can manually apply that. Later on, the advisor will also make sure that it permanently checks your system and gives you notifications about how to optimize your system even further. Now, this is all about elastic compute nodes. Now, I want to briefly pivot a bit and go into another area of elastic compute with HANA Cloud, which is about the capabilities we have with regards to SQL on files. Now, SQL on files is another great feature helping you to basically achieve a fantastic cost performance ratio with your database management solution. It gives you the possibility to access data stored in structured files, sorry for that, still via SQL as one query language. And we have announced in Q3 that we're now natively supporting the connectivity to data lake files, stored files via the SQL on files technology. In Q4 now, we're adding the possibility to integrate even external object stores into your data lake file system and also into SQL on files. So this is a great additional value, especially for all customers that already have their very own managed object store and that want to include these external object stores into our SQL on files data processing for HANA Cloud and make the files available as said to our HANA database via the structured query language. Now, what you can see on the right-hand side is how this can be configured with HANA Cloud. The configuration varies a bit depending on the service provider of the object store system, but the creation of the remote tables, which is then like the application level consumption, is all the same for all systems. So apart from the configuration via SQL, for sure, you also have the possibility to configure that via the tool. And additionally to the integration of external object stores, we now also have the possibility to integrate external data sharing being provided by Databricks. So this, from my perspective, is another fantastic addition, because I know there's many consumers of data sharing already around. And with the dedicated adapter that we now have in HANA Cloud to connect to data sharing for SQL on files as well, you can make use of these data shares also via SQL on files in HANA Cloud directly. Again, on the right-hand side, you see the configuration via SQL, and for sure also there is tooling support in the database Explorer as well for SAP HANA Cloud. Just one last comment, bear in mind that this is only for read connectivity for now. so you can consume the data and process it accordingly in SAP HANA Cloud. And that's already it in a sense with regards to the updates on elastic scalability in HANA Cloud. I know this was a lot, but for sure you will be able to digest that much better than diving into also our blog posts and into all the content that we release in addition. And with that, I'm already handing over to my colleague Rüdiger, who has like another firework of innovations in his pockets that I'm sure he wants to talk about quite a bit.
All right, then let me quickly start. So before we go into the details, let's have a look at the picture. What is multi-tenancy at all? And what are the benefits? The benefits is that a customer that has an application where many customers are using it in parallel, you can use multi-tenancy to have a very cost-effective approach by just sharing one single software instance by multiple customers, so at the same time. So you have just a very, very small footprint with your software instance, and you can serve many, many customers in parallel, which is quite common in a cloud environment. And so there is a need to persist customer data in a separated and secured way in an underlying data management layer. And this is the reason why we introduced HANA Cloud Native Multi-Tenancy with this new release, Core C4. And we introduced a schema-based tenancy model with a new database object that's called a native database tenant. And this native database tenant can contain one or more HCI containers and schemas. And on this database tenant level, you have the database management capabilities you expect for managing customer data. You can encrypt customer data, you can back up, you can limit the resources, and so on. And this provides a real tenant level isolation for all customer data in one single database instance and the application or software instance on top. So that's in a nutshell. So let's have a quite deeper look. But first of all, what is a native database tenant? Just as a more clarification, what it is, it's a catalog object in the HANA Cloud database. But it has also an additional representation in the HANA Cloud infrastructure because we have a tenant management service outside of the database that takes care of all the database tenants that you have in your sub-account for your HANA Cloud instances. And this tenant management service takes care of all tenant operations also between HANA Cloud instances. So that's something we plan in future. It's not coming with the initial release of Core C4, but it will be coming soon. And each database tenant is encrypted within customer-specific encryption key and managed by SAP. Maybe just to clarify what a native database tenant is not. It's not a BDP tenant, and it's not an application tenant. Here, you have to be a bit conscious how you use or how you apply native database tenants and how they are differ from the application tenants. What is the delivery scope with HANA Cloud Native Multi-Tenancy? Let's have a look at the picture first. I think it's easier to understand. You have a multi-tenant application running in BTP. You have your customers running on this multi-tenant application. Each customer has a subscription and an associated or assigned application tenant. And the multi-tenant application is applying our APIs of the tenant management service to manage the database tenants in the underlying HANA Cloud database instance. And database tenants in the HANA Cloud instance, they live for their own, so they do not have any cross-references. However, they can share global schemas or common schemas in the HANA Cloud instance. This is quite common. And So you can really, in this way, you can really persist data and separate data from customers, from different customers running with the same database instance and software instance. On the right side, you see some of the scope details. So you need a Core C4 release as a minimal version for HANA Cloud Native Multi-Tenancy, or you upgrade to Core C4. With an older release, you will not have these capabilities for multi-tenancy. And when you have provisioned your HANA Cloud instance with Core C4, it's enabled by default. Nothing has to be switched on or configured or something. It's enabled for multi-tenancy. It's available in all HANA Cloud data centers for Azure, or for all HANA Cloud data centers in the Azure, AWS, and GCP hyperscaler environment. You can create, delete, encrypt, and recover database tenants. So each single database tenant has these capabilities. And we will provide also an administration for database tenants in the HANA Cloud Central tooling. As said, database tenants are encrypted by default with a customer-specific and SAP managed key. You can have up to 1,000 tenants per HANA Cloud instance. And each tenant may contain multiple schemas or HDI containers. You can limit the resources per database tenant to avoid this noisy neighbor effect. And this is by just defining workload classes that are mapped to the database tenant. Each database tenant can be identified with a unique ID. And you can have common schemas as said in your HANA Cloud instance that can be shared by multiple database tenants. However, database tenants cannot refer to each other, so cross-database tenants access is not allowed. This is because each database tenant needs to have its own lifecycle because of any kind of tenant operations you can think of, like recovery. This requires really an independence of between the database tenants. Yeah, this is a screenshot from our tooling support in HANA Cloud Central. You see, we have added a new toolbar icon on the left side in the navigation bar. You can click on. In your sub-account, you select an instance, and you see all the tenants within the instance. For this example, it's just one tenant that has been created in this HANA Cloud instance. You see the encryption mode. It's SAP managed encryption. You see the tenant ID, the creation time, and you may also trigger some actions for this database tenant. You can delete the database tenant for sure, or you can create one. On the upper right side, you see this button to create a new tenant, or you can start a recovery for your single database tenant. Yeah, that's from my side in short about this new feature coming into Core C4 for multi-tenancy, and I like to hand over to Christoph.
Thank you very much, Rüdiger. Yeah, I'm also pretty excited about some really exciting new enhancements in HANA Cloud Q4 release in the area of natural language processing, specifically including our HANA Cloud local text embedding model and respective functions. So let's take a look at this release highlights. As I outlined, we are basically with a whole set of new functions based on and targeted to work and process text data in the sense of doing text analysis, text mining, text search, or building text embedding vectors using our local embedding model. We are really unlocking insights of that text data which you have already stored in SAP HANA Cloud, and by this and additional downstream processing functions provide you multiple methods to unlock that value from your text data stored in SAP HANA Cloud. So it all comes together: classic numerical categorical data, text data in raw form, text data in the embedded form, using then also the vector engine to store it, and respective functions being capable of leveraging those insights, the vector column type. That's what I mean. So let's look at the functions in detail we have released. There's a new text chunking functions in order to cut down text data to processable number of tokens, as large language models and embedding models typically have a limit of the number of tokens it can be processed at once, and that also improves performance. Text analysis, a capability which we've had long-standing in HANA on-premise, is now available in HANA Cloud. We come to that in more detail in a second. A new keyword-based text search functions, BM25, is introduced. The embedding function itself, we will look into more detail. Then functions in the area of machine learning and text mining, which can leverage the text embeddings, for example, in the area of approximate nearest neighbor search, in the area of text mining, or dimensionality reduction of those vectors. We can shrink the vector data, but kind of keep the information of the vector by, for example, using principal component analysis, and also leveraging the vector data itself as a feature along with typical machine learning tasks like classification regression. And therefore, we could be applying it to use cases like service ticket text classification as one classic example. Vector clustering is a capability we've introduced before in the previous release, and now also supporting the popular k-means clustering techniques to process the vector data. There's also further enhancements in the machine learning area. Our AutoML functions being enhanced with an outlier operator for regression scenarios, and then also our multi-label, multi-target neural network, multitask NLP it's called, now supports data training on new data, model state for faster inferences. And it's one of the functions which supports to process the vector data. So now let's look into some of the details. There's also the blog post available, which is linked here, which gives you all the insights about the, in more details about all those features. Text analysis is the first feature. Many of you know this from SAP HANA on-premise. What can we do with text analysis? Basically, by using part of speech tagging, we can analyze text and derive the grammatical categories from the words, etc., in the text documents we are processing. So we can identify what's a noun, what's a verb, adjectives, etc. That's often very useful when kind of understanding the words and notations, grammatical notations in text. Named entity recognition, even more popular. It's needed to, for example, detect names, organizations, locations in the enterprise or in the public space from text data, for example, to be able to anonymize person names in data before we pass it on for further processing. And another key technique in this area is sentiment analysis. We want to understand the sentiment expressed in the text, be it the document, be it the sentence in the text, or even a phrase or individual words kind of indicating that sentiment. So that's now supported in HANA Cloud as well. And we see there is a new procedure called PAL_text analysis, which basically composes all these techniques. The input data has a column task. That's basically where we would be specifying the individual task to be executed on the given text document or text entry we pass in for processing. So that's text analysis now in HANA Cloud. Secondly, and clearly, the highlight in this area is the text embedding model itself. Basically, as we specify a vector column for a table, we can additionally add information, and that's outlined in the documentation. that as we insert new text, for example, to the table, that it's automatically then converted and populates the text vector column here on the right-hand side. So we automatically generate the text embedding vector for the inserted text. There are basically two functions which facilitate that. One is a SQL scalar function called vector embedding, which we typically also then use at query time when we do similarity search and comparisons, where we specify here a bunch of heroes. That's the text we want to embed as part of the query. And then we specify the text embedding model, which is the one detailed out here. There's another functions in the predictive analysis library itself called text embedding. And this one is basically used if we have a larger number of batches of text bundles, which we want to convert into text embeddings at the same time. With that, really, we unlock the semantic context or the understanding of your text data in HANA Cloud by transforming it into that text vector itself. And as I mentioned, then use cases like similarity search, classification or clustering scenarios can then make use of that data. It certainly here targets primarily text data. One of the scenarios I mentioned is advanced text mining using an approximate search. So basically, in the text mining function here doesn't build on the original text itself or term frequency analysis, but rather the text embedding model, which we can pass into the function directly, or we can also pass in the original text. And it's based on an approximate nearest neighbor search, which implies that it basically has two phases. First and foremost, when the model is built, the individual text embeddings are clustered using a k-means technique in between, and then the similarity is calculated against the cent rates, if you want, of the clusters. And that's then basically also used during search time. We're always searching against the centers of the embedding groups for similarity. And with that, it's basically targets large scale data as well. And also, as we specify here, the approximate nearest neighbor search is a technique designed for this high dimensional vector data itself compared to the classical k-nearest neighbor search. So with that, we basically provide a faster text mining technique, as the model itself is kept as an in-memory, stateful in-memory model. So it's always available for search and inference. And again, we're unlocking the semantic understanding of those text documents when we do this approximate nearest neighbor search using this new advanced text mining technique. And what I'm really excited about is that our machine learning functions like classification, regression now also can utilize this vector data or the text embedding vectors. And therefore, we can understand text documents and use the vector in mix with classic, numeric, or categorical attributes to build even better prediction models in the area of classification or regression in this first release. So we can build hybrid models combining different input feature types, text originally, but actually then the text embedding vectors along with the classic attributes. And we have multiple PAL functions already supporting this. Our hybrid gradient boosting tree, regressor or classifier function is the most popular one, along with the MLP multitask neural network function, which also has been becoming very popular, but it's only newly introduced also earlier this year. And we can further boost this scenario if we take care of handling the volume of vector data we're passing in. And specifically for this scenario, we could make use of the dimensionally reduction technique. So the embedding vectors typically have a dimensionality of 768. It's the dimensionality of our text embedding model, or even larger, 1500, 3000 or more dimensions. And that imposes a key memory footprint during processing and also during storage. And specifically for these machine learning tasks, we can use principal component analysis to extract the insights using this new principal component dimensions. And there we can, for example, specify we want only 64 or 128. And with that, we reduce the memory footprint and also the runtime performance for building those models and also for inferencing using those models. So the predictive analysis library with that has been greatly enriched again in SAP HANA Cloud. As you can see here, highlighted in green, all the new functions. So it's becoming richer and richer, and text and vector data processing is really one of the new and stronghold categories of analysis functions we provide with the predictive analysis library with this release. And finally, what users are using is certainly our Python machine learning client. And with that, I'd like to quickly step over into a demo. The new release 2.23 of HANA ML provides most of those new functions. So I'm loading the package, the new package, connecting against my HANA Cloud instance. What I'm processing here is text data. The text data is from a public source, an HTSA, containing data about complaints of cars in the US for security reasons. And I've preloaded here into a HANA table. And as we look at some of the columns, it contains this component description. That's the component, what the complaint is about. And the last column here is really the complaint as text. If you look into the data a little bit further, just to understand it, give it an overview to you, we see if we filter on the full electric cars, these are the makes and brands of the full electric cars in that data, with Tesla, Toyota, Volkswagen, Ford, Chrysler being kind of the high classes here. Regarding numbers of complaints, and also if we look at the components of failure, we see electrical system, engine, service brakes, etc. are the components with high frequencies. So now let's do something with that data. We have 906 complaints. Again, looking at one of the entries here of the data set, we see component description, electrical system. And there's something with Tesla 3 as the complaint here text describes. Now let's generate the embeddings from those text data. There's a new function here also in the Python machine learning client called PAL embedding. And we can basically use that to build an embedding from this column component description. And that takes a short moment, but we can then take a look at the generated data, if you want, using that data frame. And we see behind that column, HANA Cloud text embedding, that's the actual embedding vector, which I have just created. And just for reference, basically, we're using the function PAL text embedding here behind the scenes to generate the embeddings into a column. There's certainly also the SQL function, and with that SQL function, we can certainly also translate text into the respective embedding vector. This is for the scenario of a similarity search. We want to find the complaints which kind of talk about the 12-volt battery problem. The battery is empty, and using this function basically against our vectors in the table, we get the similarity calculation. 0.7 is kind of the one with the highest similarity for this Toyota. So from the SQL side, the Python side, the PAL function side, we can leverage the embedding model for the different scenarios. And the last example I'd like to quickly show to you is that classification scenario. Again, I have my input data. I've pre-calculated the text embeddings, but also a reduced principal component vector of dimension 64. And what I'm doing now is I'm specifying the columns to be used as features to the classifier model I'm building that includes that PCA vector column. I'm using the hybrid gradient boosting classifier here to build a prediction model. It's created in this example pretty quickly, and we can now take a look at the importance of the columns with respect to explaining the decisions taken by the model on this data we use for training. And we see that the vector column, the PCA vector column, contributes for 98% of why the decision is taken one or the other way. And with this model, we basically wanted to predict the component targeted by that complaint. And just to finalize this, we can certainly then also predict with the model and take a look at the accuracy of the model. And just as a summary and overview, here this small table shows the different flavors of model we have built using only the regular features without a vector, including the PCA vector or including the text embedding vector originally. And we can see that once we use the vector columns, we greatly improve the accuracy of those prediction models as we can unlock the insights from the text in the complaints, and by that to a far better extent can predict what we wanted to predict with this model, the component of the complaint. And with that, I'm passing over to the next speaker, to Tisuk. Thank you very much.
I hope you're able to see my screen. So,
Yes.
So I'm also happy to showcase the SQL Plan Advisor for the QRC04 release. Originally released the SQL Plan Advisor as part of the QRC01 and QRC02, but it was more of introducing the foundation and some of the basic features into the HANA Cloud environment. And with the QRC04, we expect a general usage of the SQL Plan Advisor. And also we've tried to enhance the usability around using the SQL Plan Advisor. So to recap, what a SQL Plan Advisor is doing is basically it detects any performance degradation that is executing within the HANA Cloud environment. And once it is detected, it reports to an administrator that such a degradation has been detected. And right now, we put in a safety measure to actually manually start testing an alternate plan or a candidate plan that will improve the performance based on historical statistics that is captured within the ASP or plan stability. So it reads the SQL plan stability historical statistics and compare it with the current performance within the SQL plan cache. And if the current one is detected, then if the current plan has degraded performance, that will be reported, and the admin can conduct A/B testing. And after the testing, if it actually improves the performance, then advice plan is given back to the admin to apply the alternate plan or the candidate plan back into the system where it is used by the query optimizer. That is one of the features that is released for QRC04, where we are actually looking into the SQL Plan Stability historical statistics and using them. And the second part is for parameterized queries, where in QRC02, we introduced the plan variant. And and now we have integrated plan variant into the SQL Plan Advisor so that it automatically detects that a query performance is fluctuating due to different parameter values, and we apply the hint to use the plan variant automatically, and then we test if it's actually improving the performance, and if it does, we keep it in plan variant, and if not, then we go back to the current plan. So that is what is being released as of QRC04. And also, like I've mentioned, we try to improve the user experience around using these SQL Plan Advisor. So right now we've grouped the indications or advices or notifications to the administrator as a separate application card called the SQL Plan Advisor. And here you can directly know how many queries have been registered due to degraded performance. And after a testing has been tested, and how many of them actually have improvements. The advice available is automatically applied if you have the setting to auto apply. So it will not show any numbers, but if you have it as a manual setting, then the numbers will be shown here, where the customer can notice that an advice is available and apply the settings. And also, you apply the recommendation, but actually, after running for a period and the performance have degraded again, then the check required is notified to the administrator saying that it no longer is giving you the performance that it expected. So you might have to go back and redo the cycle again. So this is the process that we have introduced as part of the QRC04. And also in the details of each of the queries that have been registered, it shows the detailed testing behind each of the alternate plan. So is it actually showing improvements or not? You can intuitively check the details page and look into which plan has actually a better performance. So with that, let me just go to the screen for the SQL Plan Advisor. So like I've mentioned, it's separated out. Previously, it was part of the SQL statements, but now we've separated into a separate application card. And if you click, it will go directly into the registered. We've grouped them to detected or registered, which means degraded performance have been detected. If it's actually being tested. So right now, this is one manual step after registration to safeguard production environment. We have this test button, but gradually, once we have matured this component, that we will have it automatically start testing. But as of now, it is required to start and manually start the testing. And as you can see, it moved on to testing. And once the query is being executed, it will actually start testing. And currently, it only shows the statistics based on the current plan cache. But if we go into already tested plan, it shows that the original plan, current plan, in the plan cache have bad performance, but in the ASP, it showed better performance. So here it is recommended that the existing plan shows better performance, and you can just apply the recommended plan. And once the advice has been applied, all following subsequent execution will use the existing, the historical plan to improve the performance. So that's it for my demo, and I'll hand it back to Susan.
Thank you very much, Tisuk. That was a really, really nice overview. So we're already a bit longer than expected, but that's absolutely fair. So don't worry at all. I only have a few words to say. Thanks to all the speakers. It has been a lot of key innovations we just delivered with our Q4 release. So congrats and exciting new innovations coming in HANA Cloud. I know it was a lot of content, but I want to close this webinar with even more content. So if you want to have a look at the top new features, we, as always, published our teaser. And if you want to read more in detail, definitely check out the various blog posts we're publishing with the release, as well as our help documentation. And always make sure to follow our What's New tag in the community to always get the most recent information about SAP HANA Cloud. With this, thanks for joining today. Thanks for looking into our Q4 release of SAP HANA Cloud, and see you with the Q1 release in 2025. Thank you very much and have a good time.